know Justin's ready for Leetcode because he's spamming his
Let's go.
keyboard. Let's go, Leetcodes. Alright. Alright, peoples, are y'all here? Are you ready? Okay. So Leetcode Friday for this week was actually Thomas, you recording? I'm gonna assume yes. Okay. So Leetcode Friday this week was focusing on hash maps. We're gonna teach you guys how to do how to use hash maps, what hash maps are, and why Python is the best language in the world for Leetcode because of things like default dictionary and cool things you can do with hash maps, and other data structures. So first though, we're not gonna do hash maps. We're gonna just do this quick 111 problem. So this question says, given a non-negative integer x, return the square root of x rounded down to the nearest integer. This is actually a pretty hard problem. I don't know. When I read the solution, so I was kind of confused, but honestly, this is a good example of why Python is the best. Right? You ready? Type in return square root x. I think it's math at square root. Oh wait, which one was it? Oh, maybe it's int. So you can make this an integer. Does this work? Let's see. It works! So, why do more work when you can do less work? Honestly, if you're in 111 and you just did this where you just returned the square root by just using the square root function, I would give you full credit for this. This question is just kind of silly. If you look at the solutions, they're actually pretty advanced. For example, one of them is literally using binary search to create a square root, or some weird exponential stuff with logs and everything else to come up with a square root. I don't like this problem at all. But if you literally just do return square root using your built-in library functions from whatever language you use, that's good enough, because this is a good example of why do more work when you can do less work. And this is going to be the moral of today's story. Why do more work when you can do less work? AKA, you should use Python because you can literally just do this and it still works. Even though this is not what they meant for you to do, they wanted you to actually solve it by coming up with the solution. Honestly, they're never going to ask you as an interview, and they seem kind of confusing. So for a 111 question, I would just be okay with you submitting this. All right, so that's pretty much it for square root. Not much to talk about, but now let's actually talk about some more interesting problems. We're gonna talk about hash maps. So let me quickly swap over to my iPad, and I'm gonna teach you about hash maps from scratch. All right. So y'all can see this, right? You can see my little iPad?
Yes.
Cool. All right. So, let me delete this. I don't need this anymore. All right. So you guys know about arrays. You've used arrays before. An array is something like this. You got 1, 2, 3, 4, 5. Right? Here's an array of size 5. Right? And we call this array using different indices. Right? Let me actually make it so a little bit different numbers so it makes a little bit more sense, because it's a little confusing. Let's do, I don't know, 5, 20, 42, 65, 90. All right, so here's an array of some numbers, and there's 5 of those numbers in the array. These numbers are little boxes in memory, right? Here's a little box, and each box is holding this number, and we call it position 0, 1, position 2, index 3, index 4, right? So arrays are indexed from 0 to 4. The index is sort of like the key of where we're at, right? So if you want to find array 3, what would this output? If we look at the third index of the array, what's the output? Can someone answer?
65.
65. Yes. So what we're doing is we're literally looking at the index, and we're just going straight there. We don't have to go through this whole array and search it. No, we're literally just going to go up to the point in memory, and we're just going to go straight to number 3, and that gives us 65. All right. So when we're searching through an array using an index, how many steps does it take to do that? Does anyone know how many steps it would take to go into index 3 in an array?
1.
1. Yeah, you're literally just going, you're just searching the third index of the array. So we talked about big O last time. This would be a big O of 1 operation because it's constant to index into an array. Right? So now a different question. How long would it take how many operations would it take us to go through this array and search for, say, 90? Say we want to find 90, and we start from the beginning, and we're just linearly searching through the array. How many steps would that take? This is not a hard math problem. Can someone answer?
5. 5. Or
Yes,
N.
5. Exactly. So we have five numbers in this array. It would take 5 steps. Worst case scenario. If we had 9,000 elements in an array, it would take 9,000 steps to hit the last number, which is 90. So worst case scenario, right? If we have n numbers in array, right, then it'll take big O of n, because worst case scenario, we would have to go to the entire array to search it. This is where arrays can be a little bit problematic. So now here comes in the hash map. So remember how we talked about how arrays are indexed from 0 to 4, right? In this case of a size 5, it's 0, 1, 2, 3, 4 as the keys, right? Index 1, 0, 1, 2, 3, 4, and the values are 5, 20, 42, 65, 90. So I'm going to give you sort of a very high-level idea of what a hash map is. This is not exactly how you consider a hash map, and it's sort of like a hacky you just use a type of example, because if you really wanted to get into how hash functions work and open addressing and all that stuff, that's for 313. You don't have to worry about it. We just want to know how we can use hash maps to solve this problem of indexing into array, searching an array being O of n, right? So in a hash map, we kind of think of it sort of like a dictionary. In Python, it's actually called a dictionary. So in a dictionary, we have, say, like a word, right? Let's say we have something called book, right? This is our key in the dictionary. There's only one word book in the entire dictionary. And book is, here is some definition, right? If we want to find book in the dictionary, we just look up the word book, and here it is. It's sort of like the same thing of going into an array and say, instead of 3 being 3, what if we call this book? If we just look into book, we see 65. That's sort of the idea that we're trying to do with a hash map. So now let me just explain it and draw it out, because I think it'll make a little bit more sense. So instead of using indices and numbers as our indices, what if we just use whatever we wanted as our keys? So what if we had the same array, right? 5, 20, 42, 65, 90, right? And what if instead of just indexing from 0 to 4, what if we call them whatever we want? So what if we call this A? So we're counting, say, numbers of A, and then B we can call this, and then C, and then D, and then E. The reason why I'm using characters is actually because this is going to work for one of our problems later on in Leetcode. So now we've mapped A to 5, B to 20, C to 42, D to 65. Oh, whoopsie, I typed in D twice. And E to 90. All I did was, instead of just using the basic indexing of 0, 1, 2, 3, 4, I changed it. So now we're kind of using whatever we want as our indices of an array. This is sort of like a very hacky way of thinking of what a hash map is. It is not what a hash map is, by the way, but this is sort of how you can kind of think of it. You can think of it as having your own indices, right? Or your own keys, rather, that can be anything, rather than just 0 indexed. Does that make sense? 0 indexed. So this is where so now we want to search. Say we're like counting how many letters we have in a string, right? Say we have a really long string, and we want to count how many there are. What we could do is we could have A, right, as a key in a hash map, and we can go through an array, the string, and every time we see that there is an A in that string, we can add +1 to this value over here. So if we have 5 A's, it'd be 5. If we have 6 A's, it would be 6. Doing this is really helpful for organizing our thoughts, and it's going to help a lot. It'll make a lot more sense when we do Leetcode problems. But actual way that hash maps work, it would be in Python, you would have the curly brace, right? Key, some value, key to value, etc. Value 2. This is how it would look like in Python. And again, this would be like saying in an array, index 0 is 6, index 1 is 20, index 2 is 42, and so on. Same exact idea, but we're just looking at it differently, and we're giving our own idea of what a key is instead of thinking of the indices. All right, so that's just a quick overview of how you can think of a hash map. And again, this is not what a hash map is. It's a pretty complex data structure, and again, the reason why we use Python is because it's built in. You literally just use curly braces and it's already built in. If you did this in C, for example, you would have to build your own hash map, and that would be like literally 400 lines of code. Well, not literally, but I'll show you guys. Hash map in C. So like if you wanted to make your own hash map, look at all this. Look at all these words. Look at all of this. Why would you do all of this from scratch? Right? When you can just use this. That's so much easier. All right. Now let's get started with our first Leetcode problem, and then we'll show you how to use hash maps for a Ransom Note. So Ransom Note, the question says, given two strings, Ransom Note and magazine, return true if Ransom Note can be constructed by using the letters from magazine and false otherwise. And I'm just going to take a screenshot on my iPad. The examples here are, for example, if the Ransom Note is A, and the magazine only has the letter B, output is false. I'm going to draw it out on my iPad in a second, so it makes a little bit more sense. It's sort of like in the movies. Like, if you ever watched like some of those old school like comedy movies where like someone kidnaps their kid, and it's like, I have your kid. You have to give me $5 million to get your kid back. They give it to you using like a magazine cutout, saying so that way you can't tell the handwriting, you can't tell who it is. It's just like sort of like a joke little question to kind of give you something to laugh about, think about. All right, so back to my iPad. All right, so Ransom Note. Given two strings, Ransom Note and magazine, return true if Ransom Note can be constructed by using the letters for magazine and false otherwise. That's what's pretty much saying is, are the characters in Ransom Note all in magazine? Right? Are the characters in the Ransom Note all in the magazine? So if the Ransom Note says, Justin, actually has to be all lowercase just to make it easier. Justin is in danger. Right? Justin is in danger. Ignore the spaces. There's no spaces in this, but just pretend there are no spaces, right? Justin is in danger. And then the magazine is something like danger. Justin, a student, I don't know, who is in QC, save someone. Here's some magazine article that just, I don't know, Justin saved some random person from like a scary bear, and it's in the magazine. But then someone kidnapped Justin, and they wrote a note saying Justin is in danger. Here's a question. Can you make this sentence, Justin is in danger, from this magazine? Just from eyeballing it, do you think we can make this sentence in there?
Yes.
Yes, we can. Justin is in danger, because over here, we see danger, we see Justin is in. So we would return true, because Justin is in danger is inside magazine. All right, so that's kind of the conceptual idea of what we're trying to do, and hopefully it gives you a bit of a laugh because Justin hopefully is never in danger because he's too precious and we don't want to hurt him. All right. Love you too, Justin. All right. And obviously over here there's just some more boring examples, right? Ransom Note has AA, and then magazine has AAB, right? There's two A's and there's two A's, so since there's two A's in both, then true. Over here, there's two A's and there's an AB in magazine, so note two A's, only one A in mag, right? That's not good. And over here, there's an A in Ransom Note and a B in magazine. There's no A in magazine, so there's no way you can have the Ransom Note in the magazine. That's the problem. All right, so let's solve this problem. So you have an array, sorry, a string, which is technically an array of characters, right? And let's say we have, let's do, I guess AA. A, B, C, A. This kind of reminds me of our Brennan because she does something like this. Right? Here's Ransom Note. And then here's magazine. A, B, A, C, B, A. Whatever. This is literally looks like something that Obrenick would do in her like regular expressions homework. So here is what we're gonna do. What if, right? What if I propose to you that we use the hash map? You know, it's kind of like, oh wait, we're learning about hash. What if we use the hash map? And what if we counted how many times a letter shows up in Ransom Note and in magazine? What if we said like, hey, there's three A's in Ransom Note, right? And there's 1, 2, 3, 4, 4 A's in magazine. That's good, right? Let me add a D over here to make it false. Here in Ransom Note we have 1D, 0D in mag. That's false, right? So let's do a counter. So in Ransom Note, actually, let me do for magazine first. So we should always start from the big one. Let's do magazine. So magazine, we have A, that's 4 of those, right? B, we have 1, 2, we got 2. 2. C, how many we got on the ransom? We got 1. And then D, we got 0. So we actually wouldn't even have this in here. So it would just be A, B, and C. This is the entire counter of magazine, right? So now we have our counter. We have our hash map. We have 4 A's, 2 B's, 1 C, and that's all we have in magazine. Next, let's go for each character in Ransom Note. So here's Ransom Note again. Call it RN. For each character in Ransom Note, what if we said that if this counter, right, the character, or let me spell that. If the character counter is less than or equal to 0, right? So that means if it doesn't exist, then that's false. So say we're looking for D, right? Does this exist in magazine? No. The counter would be 0, just by default. So since it's less than or equal to 0, then that would be false. And then what if for each, after we iterate through each character, we decrement the counter? So say we're here, right? We're in A. A right now is 4, right? That's good. We're good to go. Let's move this down to 3 because we went down 1. We saw 1, right? Now we're in the second one. A, again. Right now, we're at 3. That's greater than 0. We're good. Let's decrement it by 1. We saw second A. Now let's go to B. All right. B, we have 2 in magazine, right? 1 and 2. So we see a B. We move it by 1. So now we're 1, which is greater than 0. We're good to go. Now we're at C. Because we're going for each character. C, we have 1. Perfect. So let's move it down to 0. We're still good because, again, we check this first. First, we check if the character counts less than or equal to 0. And then character count minus 1. So then we're here. Then just erase this. There we go. So now we're back to A. A again, we're still good. We see another one, so we subtract 1. Now we're at 1. Still good. And then now we're at D. Do we see a D? No. But then, so then again, if the character count is less than or equal to 0, then it's false. So since the second we checked it, it's already at 0, right? C is different because we made C 0 after checking it. We checked it at 1, then turned to 0. To 0, right? But here's different. D, we actually were at 0. All right, so this is the solution for a ransom note. So just to scroll out, just to summarize what we did, right? We used a hash map. We counted every single letter that we have. So it'd be technically as a for loop, right? For each character in the magazine, we're going to set the key to each letter, right? If the key exists, then we're going to add +1 to it. If it doesn't exist, we're going to make it equal to 1. So we're creating the keys as we go. Then after that first for loop, we'll do a second for loop where we go for each character in the ransom note, and then we just check it based off the indexing of the magazine. Because again, remember that indexing in a hash map or array, if you know the key, right, is O of 1, which is instant. So it takes no effort at all. So overall, by doing this, we're doing 2 for loops. We're adding the characters to our hash map using magazine, and then we're iterating through the actual ransom note. Say if the size of magazine is M, and ransom note is N, this would be big O of N plus M, which is the time complexity of this problem. All right. So just again, I'm going to show us for one last second. Just take a look at it. Then we're going to turn this into code. Okay. All right. So here is where we're going to start using Python for good. So remember how I talked about we're going to go through magazine, and for each character, add a counter, right? So if we had 4 A's in magazine, we wanted to make, for example, A equals 4. If there are 4 A's, as an example. So technically this would be something like for character in magazine, and then make a hash map, add each one, but that's mad work. We're going to use Python. In collections, which is a default library in Python, so it's built in, they actually have a counter hash map which does everything for us. So what we just did, magazine count equals counter, right? Magazine. What this does is exactly what we just talked about. Using counter, it creates a hash map that counts every single character in magazine, and gives you a count of how many times that character shows up. So exactly what we just talked about, we literally just used the built-in function for that. So we just saved like 4 lines of code. So I'm not even have to bother with that. I'm just going to use counter. And there we go. We have a hash map counting every single letter. Cool. Problem solved. Again, this is why Python's the best. So now that we have our magazine hash map, let's go over the ransom note. All right, so now let's do a for loop. And again, this is why Python is best for a character in ransom note. Super, super simple. For each character in the ransom note, like you can't get more English than Python. In C++, as an aside, this would be something like for int I equals 0, I is less than ransom note dot, I guess like length, I think. I don't remember. I plus plus do stuff. So instead of doing all of this work, we can just say for character in ransom note. Beautiful. I love Python. Again, we just save so much work by using Python using the default counter from collections. All right, so now we have this. If the magazine count for this character, right, is less than or equal to 0, then we return false. This means there are more A's, for example, in ransom note than there are in magazine. All right, and then we're just going to decrement the count of the character like we talked about before. So I'll just be magazine count character minus equal 1. So if you look at this, the way we this code, it looks exactly like if it was an array, right? We're looking at the variable name and we're indexing into it. So in this would be the current character should be A, B, C, D, E, F, G, whatever, right? And we're subtracting 1 from its count. Same thing as an array like we talked about. Instead of the keys being 0 index, it's whatever you want. So the index are the characters, right? And then if we've gone through the entire ransom note without returning false, we're good. And now it'd just be return true. Right? So this is the entire thing. If we run it, should be good. Cross my fingers. Yep, it works. Cool. So we just solved the problem. If you submit it, there we go. Again, the beats type of thing, it doesn't really matter because here I beat 87% and memory beats 96%. If I submit it again, I'd be 89% and I'd be only 80%. So don't worry too much about the beats. Just do your runtime analysis. So over here, the analysis of this is big O of n plus m, with n being the length of the ransom note and m being the length of the magazine, because we have to go to the magazine once to add them to the hash map, and then we have to go to the ransom note once to compare them. For time. And that's it. Any questions from ransom note? Any questions at all? Something I can clarify a little bit better? Speak now or forever hold your peace. I'll give you 5 seconds while I take a screenshot of the next
Pretty
question.
good explanation, but I guess to note on the power of Python, I'm writing this right now in Java and I'm still not done. So I'm still doing my solution right now.
Yeah, so like I said before, like this is why you want to use Python. So lots of you might have not learned Python before because you learned C++ and Java in Queens College. But if I go through this problem, I guess in like a tutorial or whatever, like they have solutions. Like, oh, actually, it's not too bad in Java, but but it's so much easier. Like, oh my God, look at this. Look at all of these characters. Look at all of these lines of code. Oh my Jesus Christ. 40 lines of code. I have 19 lines, and those are all half of them are comments. Like if I took away the comments, which I'll share the code for you guys once we're done as well. So yeah, rather than having 40 lines of Java code, we have 10 lines of Python code. It's so much easier to use Python because again, we saved ourselves a lot of work because instead of having to go through each to do a for loop for the magazine, we could use counter, and then afterwards, hash maps in Python are so much easier. So even if you don't know Python, there are so many free resources to learn Python. One of my favorites is CS50 Python. So CS50P, it's free. It's from Harvard University. They teach you a full complete course on how to use Python, and they have lectures, they have notes which are absolutely amazing. Like look at these beautiful lecture notes. They have problem sets. If you take this CS50 course, which you don't have to be in any CS class in the school to take this class. You can do this even if you're 111. I did this before I started Queens College. So I learned Python and I did this entire course before even taking 111. I recommend it if you have time. You'll be a Python master by the time you're done with this course. But yeah, this is why we use Python. We want to take advantage of these built-in functions and methods that Python has, because when you're taking a technical interview, say for like Google, Amazon, Netflix, or whatever, you have a time limit. You only have like 20 minutes to solve their Leetcode medium level problems. And you're going to spend all of that time reinventing the wheel and making up functions that already exist in Python just because you want to use C++. That's going to just waste your time. And if you don't solve those problems in time, you're not going to get the job. You're not going to get the internship. So why would you waste time using a more inefficient language in terms of how much you have to write when you can use something that's super easy, super quick, and gets the job done? They want to know that you can solve the problem, not just use C++ and flex on people, that you can create your own hash map from scratch. All right. So moving on, second problem, majority element. All right. Here's the question. Given an array nums, so again, this is which level is this going to be? I think this is for like, let me see. Which one was it? What did we put? This is for, okay, so ransom note is for those who are 211 to 12, makes sense. So now if you complete 211 to 12, this should be pretty easy because again, this is a hash map. So given an array nums of size n, return the majority element. The majority element is the element that appears more than n over 2 times. You may assume that the majority element always exists in the array. Pretty much what it's asking you is to say, find a number that shows up in more than half of this array, right? Numbers equals 3, 2, and 3. 3 shows up 2 times out of the 3 possible numbers. That's the majority element. Numbers here is 2, 2, 1, 1, 1, 2, 2. 2 shows up 4 times out of the 7 possible numbers, so 4 over 7 is greater than 1/2, so the number is 2. All right, let's go to the conceptual diagram that we can draw out. Also, whenever you're doing Leetcode problems, I really recommend you draw it out first. Think it out as you would just with anything else. It helps a lot with solving these Leetcode problems. Don't just start coding. You should draw it out, come up with a conceptual idea of logicking it out, then create the code. All right. So here we have an array, and we have to find the majority element. I wonder, what can we use to count how many times something shows up? Does anyone care to guess what we could do to count how many times something shows up using whatever keys and values we want? What data structure can we use? Come on, guys, I feel like you're the explorer.
In the chat. They said counter.
Yes, we use a counter, but what's the data structure called? It's called a hash map. A hash map is the actual name of the data structure. So when you talk about hash map, this relates to C++, Java, Python, C. Well, you have to make your own hash map in C, Rust, JavaScript. They're all called hash maps conceptually. A counter is actually a function. It's a different class that Python uses that uses a hash map, and it implements its own like default functions for counting stuff. So that's not really a data structure. That's just a function that you can use, which is why Python is better. But we're using a hash map or a dictionary, which is what Python technically calls it. So we're going to use a hash map. So here's another thing that we can use with Python that's really cool. But I'll talk about it in the coding situation when we actually code it out. So here, problem is, find the number that shows up over half the time. If you search the array. That's a problem. Find a number that shows up over half the time if you search the array. And that's it. So how would you be able to find out if a number shows up over half the time? Count it. So say we have, right, we're counting the numbers. Say we have, say number 2 shows up 10 times. The number 4, or I guess 5, I was writing it already, shows up 5 times. The number 6 shows up 8 times. Right? Which is the majority number? It would be 2, because it showed up 10 times, because this is the biggest number. That's sort of what we're trying to figure out. And the reason why we can use a hash map is because we can give each number that's in the array, because again, the array could only have maybe 1 or 2 numbers. We don't want to add an array which is like literally 0 to like 99 million, whatever. That's kind of dumb. Instead, we're going to create our own keys, and if we see the number existing, we're going to use that, which is why we can use a hash map. All right. So then the way we're going to solve this is we're going to go to the array. So say we have an array called nums, right? Nums. Make this blue. Let's say it's 2, 2, 1, 1, 1, 2, 2. That's the example they gave us, right? Let's go to this array. Let me erase this. All right, so let's go to this array. So for each number in nums, right? For each num in nums, we're going to add 1 to the counter. So say we are in 2. Let me write it over here. 2. And then we're here. So first one we see we add 1. Here's 1. Then we go here. We add 1. That's 2. Right? And then we go here. We add 1. So that's 1. Go here. 2. Here. 3. Here. We find another 2. Update that to 3. And now we find the last number. Update that to 4. Right? So this is how we create the counter. While we're going through each of this loop iteration, we always have to compare it. So before we even get to, say, the next number, so while we're still in the first search, let's do a little check. So let's say if the, so say we have this account, remember? If count, and we're indexing into the num that we're counting, right? So for num in nums, if the count nums is greater than the majority, which, sorry, I forgot to mention, let's set majority equals to 0, right? Because we're counting to find out which is the majority element. So we're just going to set it to 0, which is some arbitrary number. You could also do like -1, whatever. Doesn't really matter. Right? So if the count nums is greater than majority, so if you do 0, it's just for default going to be the smallest number. Right? Then you could say the answer equals the num. And then majority equals the number of times this num shows up. So all we're checking is that the majority is how many times currently the biggest number is shown up. So say we're here and 2 has shown up 4 times, right? And 1 has shown up 3 times. The majority would be 4. Just because it's the biggest number that we have so far, right? So say we go to 2, right? Here we're at 2. So if the count of 2 equals, say majority was actually the one before, would be, say technically it's actually 3 right now. So majority is 3 because of here, and also because of here. Count 2 equals 4. And then 4 is greater than 3, because 3 is majority, then answer equals 2, because that's the number that we were searching at just now, right? And then majority equals 4, because that's the count that we have for 2 so far. All right? And that's the entire solution. So just to summarize, we created a hash map that counts how many times each number shows up, right? So for each, and then while we're creating that hash map, we're constantly comparing it. But as we're after we add one to the count that we search in the hash map, we're gonna then compare it, and we're gonna say if the current count of the current number that we're at is greater than the majority. So say we have 3 2s right now, and the majority right now was like say 2 A's, right? Then we're changing the answer from A or 1, I guess, to the number. Sorry, I started switching up with characters and numbers, but this is the logic. All right. Any questions on the conceptual idea before you move on to the code? No. All right. So let's move on. All right. So now we are here to our majority element. So here again is where Python is the best. If we just created a hash map and say, I'll just do it right now, just to show you, right? Well, let's do this problem with a regular hash map. Majority equals 0. So now we set up with a hash map, it's empty, right? Majority equals 0. For each number in numbers, we're going to add 1 to that count. Okay? If the count of this number is greater than majority, so say majority is 3, we just found 4 2s. Oh my god, double parentheses. Right? Then the answer equals the number we have, and then the majority equals the count of that number that we just talked about. And that's it. Return answer. But we're gonna get an error. Key error. Count num plus equals 1. So the key error 3 for when we added this number, which 3 I guess is the first number that they gave us, it just doesn't work. Reason why is because the key doesn't exist in the hash map. How can we add +1 if there's no key called num in this hash map? This hash map is empty. There's nothing there. So this would cause a little bit of trouble. You'd have to add a couple more lines of code. But again, why do more work when you can do less work? Let's be smart and use Python for its full advantages. So instead of having just an empty hash map, here's another cool thing from collections. It's called default dictionary or default dict. And what we're going to do is the same thing as a regular hash map, but we're going to actually make it so the default key value, whatever we add a key, the default value is going to be always 0. So this is the syntax for it. Lambda is just Python stuff for a small, it's like an anonymous function technically. So pretty much we're creating a function that whenever we add a number to this hash map, it's going to be default value is 0. So just by doing this, it means, let me go back to my iPad. So before we had a hash map and it was empty. We tried to add 1 equals 1 plus equals 1 equals 1, right? Plus 1, whatever it is, right? There'll be an error. 1 doesn't have a value. Technically, it's null. So instead, we can have a dictionary where it's going to be empty, but then every single thing is 0. So when we add 1 to it, it becomes, you can just add +1, and it just works. It just saves you time. Everything is default to 0 by doing that. You can even do a default like a list. So if you use default dict, you can do something like whatever, right? It doesn't really matter. and then it could be just an array, and you have empty arrays, for example. So default dictionary gives you a default value to input into your hash maps. So if we use default dict, look at that, it works. So that's the solution. Again, don't worry about the beats. This is the efficient solution. The reason why it beats is because their built-in functions in Python are actually compiled in actual C, and C is a lot faster. And some people cheat and they use they probably use something like, I don't know, return max or something like this, and like something like that, which is cheating, and it's technically more inefficient. But in terms of Big O, but Python is just weird like that because it's so don't worry about that. But if we do our Big O analysis of this problem, right? We're creating an account, which is Big O of n, right? Because we're going through. Actually, wait, sorry, just kidding. We don't go through each. So all we do is do one. So we are just iterating through nums. Sorry, this actually doesn't take any time complexity. If you have a for loop, that's usually O of n. So time complexity is big O of n. Because if we have n numbers in nums, you are going to have to iterate that n times in nums to find your counter. That's pretty much it. My bad. So the time complexity is big O of n. Any questions on majority element? I'm gonna take a screenshot for the next one, but anyone have any questions at all? Any questions about how default dictionary works? Or how hash maps work so far? No? Alright. I'm gonna take the next screenshot, so now we're gonna do the more difficult problem. Oh, someone just
I did this question in Java. I'm gonna send the solution to that. And it's basically the same approach, but I'm just gonna send it in the voice channel chat for this question.
Where's the voice channel chat? Oh no, I'm a boomer.
The voice channel we're in right now, if you just click the chat button, like go above your name.
Oh.
See that? Yeah.
Oh, you can do that. Oh wow, I forgot that. Cool. All right. Yeah, so see, look at Justin's solution, like, and we'll compare like the length of it. So here's my Python solution, 10 lines. And if we go into Java, that's 19 lines. Oh, and you get a compile error, so did I copy it wrong? Justin. This doesn't work.
I haven't what?
This doesn't work.
Did you forget to copy it? Oh,
No.
I forgot one extra part. Hold on. Wait.
Either way. Yeah.
Here you
go. Yeah. Just
okay, there you go.
There we go. All right, so Justin's Java solution is 22 lines of code. And you have to make a hash map, you have to do hash map brackets integer comma integer brackets map equals new hash map brackets integer comma integer brackets open close parentheses. And then you had to do all if map contains key nums I. Oh my god, this is absolutely horrendous. Like, this is just so verbose, and this is nothing against, like, Justin's solution is perfectly efficient, but if you're trying to remember all of this syntax in a coding interview when you're like in front of 5 like engineers and like they're judging everything you do and you forget to use the new keyword or something, that's not good. When instead you can just use Python and use like five characters per line practically. Like, this is why we use Python, guys. This is Java. which is, to be fair, one of the most wordy languages in the world. But like all of these words just to make a new hash map, right? Well, you can just use this in Python, you know? That's why. All right. So moving on then to our next question. Group anagrams. Let me just copy it to my iPad. Hopefully these solutions are a little bit better than last time. I prepared a little bit more. I'm trying to become like Leetcode Junior. All right, let me share my iPad again. All right, cool. We are in. All right. So group anagrams. This one was actually this one's crazy. So the optimal solution is kind of insane. It makes sense when you think about it, but I don't think you would think about it unless like you actually um know about how to do this beforehand. But I'm going to show you both a inefficient solution that is big O of n log n, and then I'm going to give you a O of n solution, which is a lot more efficient, but also a little bit more confusing at first. All right. So, given an array of string strs, group the anagrams together. You can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So, also, if you hear my guinea pig screaming in the background, I'm sorry. I think they
Yeah, I've heard that. I have something in my room.
no, I have guinea pigs, and they are screaming bloody murder right now because I think I made some noises that sounds like I'm making them food, so they're kind of screaming. So sorry about that. I'll post a picture of them later so you can have a little pig tax. All right. So yeah, they're cute as hell. They're also really silly and scream for no reason. All right. So an anagram. Anagram just means that the character, the word that you have can be spelled using the same exact letters. So 8 and T are anagrams. Because look, if you move the A over here, it becomes T. I can't spell T apparently. T. Does that make sense? Anagram is just if you can rearrange letters, you can make a new word. So another one would be eat, right? If you just move this T to the front, it becomes eat. So these are all anagrams because you can create different words using the exact same letters. You're just rearranging them. So that's the hint. Rearranging letters. Letters are organized in different ways. So what do you guys think means that we could do? I'm gonna ask for you guys' opinion. What's something that you could do if the letters are rearranged differently? What should we do to make them kind of seem similar?
You can arrange them in alphabetical order.
You can arrange them in alphabetical order. And what do we call that in terms of
sorting?
we can sort it. Yeah, we can sort it. And so we have 8 T eat. If we just sorted them, it would be AET, AET, AET. Are these the same words? Yes, they are the same words. Therefore, they are anagrams.
So in this problem, could we like divide each word into different letters and have it a set, and then see if each word matches every string in the set?
I sort of, yeah. So I'm gonna show you. Yeah, sort of, yeah. I'm gonna show you how I used a hash map and a sorted stuff. I'll show you what I did. It's literally 4 lines of code, so it's nothing really crazy. But I'm gonna show you the conceptual idea. So this is the inefficient version. So this would technically be n log n because we're sorting, but I'll explain more when we get there. So right now we have these things, and what we want to do is we got the idea. We want to sort them because if we can sort this list, so see over here we have strs, right? let me do a different color. Here we go, stirs, right? We want to sort these characters. And then if they are an anagram, right, then we want to turn them into a list. So then it would be 8, T, E. These are anagrams. So we add a list, and then the next one would be bat, because in over here we had bat. See over here, right here, bat. And then we have another list, nat, tan, because these are all anagrams. So this would be a array of an array, 2D array technically, if you want to call it, or just a list of lists, right? And each list containing all the anagrams that exist for each combination of letters. So this could be AET. So if it's AETs, they're all here. And then BAT's the only one, which is ABT, would go here. And then ATNs are over here if we sort them. Does that make sense? That's using the sorting method. So the way we can do that using code, let me just drag this bad boy down here. All right. A little bit more. Whatever, it's fine. So the way we could do that is we could use a hash map. What if we use a hash map? And again, here's where Python comes in handy. What if we use a hash map where the keys are the sorted strings and the values are the actual strings? What if we did that? Where if AET, right, is the key, AET, right, the value would be 8TE eat, right? And then ABT, which is bat sorted. So anytime we see ABT, it would be just bat in this case. And then ATN, the key, the value would be nat and 10, right? And just return, so this calls answers, values. And that's all we would have to do. So all we're doing is we're creating a hash map, right? And for each hash map key, we're going to, for each string in the stirs, right? So for a string S in stirs, right? We're going to create the key of answers equals the sorted, right? The sorted version of S, value of answers equals append any string that is equal to sorted string, right? And that's it. That's literally it. So we have, again, just to reiterate what we did, we realized that if we have anagrams and if we just sort them, right, if we sort the letters of the anagram, they are equal. So if they are the same thing, right, we can use that as a key. If the sorted version of whatever string we're currently on is equal to one of the specific keys, we can append that as a value, turning it into a list. And that's all we're doing. So again, Python, we're going to use something called default dict rather than a regular hash map. And we're going to initialize it with a list. So what this does is that we'll just have nothing, right, as keys, and every single key is just going to have a list. And that just makes it easier for us so we don't have any key errors. Because again, why do more work when you can do less? Just use the stuff that you have built into Python to your advantage. Because you only have so much minutes in a technical interview, you don't want to waste your time with all that stuff. Also, sorry for my guinea pig screaming. All right, so group anagrams. Here we go. So, like we talked about before, we'll make a default dict called answers. So it's from collections, default dict and I can't spell. There we go, collections default dict, and we're initializing to the list. So make a hash map values default to empty list, right? And then for string in strings, strs, right? But for each string in strs, the key of answers is going to be sorted s, and then we're going to append s. And then I'm going to show you actually that this is not going to really work, but then we'll just return answer that values. So this won't work at first because this is just a Python thing, but it's going to say type error unhashable type list. You technically can't have a list as a key in Python because it's something called a mutable data structure. So just to fix that, you can just make this a tuple. A tuple just means that you can't, when you have tuples, the same thing as a list. Tuple is like a list, but you can't modify it. So all we're doing is that Python doesn't like when you use mutable data types as keys, so you just turn it into a tuple, but it's literally the same thing. So all you're doing is for each string, right, you're sorting that string, turning it into a key, and if it exists, then you're appending that into it, and then you return it, you're good to go. See over here, strs eat t10 8 nat bat, and then you have your 3 outputs, right? It's sorted differently from what they expected, but that doesn't really matter. It still accepts the problem, and if you submit it, it's pretty efficient, but not really, but it works, you know. Any questions on the sorting? Oh, so before any questions, sorry. And this would be big O. So for sorting, it's always going to be big O of n log n, right? And then we are also going through each string. Say size. Why are people revving their motorcycle outside? Size M.
George,
Yeah.
you're saying for your hash map for the values, you're putting that as you're basically putting the values as a list, correct?
Yeah. Sorry. Let me close my window.
Yeah.
People are revving their motorcycles for some reason. Oh my god. Yeah. So what we're doing is we're making a list, right? And say we have. So what's the saying is, so say s equals eat, right? Right? So in sorted, s is going to be AET, right? So what we're doing is answers is the hash map. And then so answers key, the key would be AET. That's pretty much what we're doing, right? Answer is technically just AET. And then we're appending it, because that's just like the that's just the syntax we use. And we're appending eat. This would mean that in the hash map, AET, the value would be eat. Does that make sense? Yep. All right, so sorry, I was going through the big O. So sorting is n log n, and say the size of strings is m. So therefore, the big O would be, I think it'd be m times n log n. I believe it would be around that time complexity. So it's pretty inefficient, but it works. All right, any questions on this sorted method of doing group anagrams? This is the easier, it makes a lot of sense. I'm going to show you a crazy solution afterwards that is O of n. Any questions? Nope. All right, so let's move on back to the iPad. All right, so now I'm going to show you a crazy solution that is a lot more efficient, but also just kind of crazy. Let me just quickly write it down for myself because it's annoying to remember. Second. All right. I'm gonna try my best to explain this one because this is a bit of a this would be, I would consider, like a Leetcode hard if you come up with the solution. I personally didn't come up with the solution. I had to understand it first. Because it is pretty advanced, but it uses a hash map again, and it'll give you a way more efficient solution. So I would consider like this solution to be more of a hard solution than the medium solution that we just came up with by sorting. All right, let me just erase all of this garbage. Can I erase faster? I'll just move all of this down. Jeez, whatever. All right. Oh, there we go. All right. So again, same thing. We're trying to find the anagrams, but let's be smart about this. So we talked about before about using counters, right? We counted the letters in Ransom Note. We counted majority element, the amount of times the number showed up. We can do the same thing in group anagrams by using a counter. However, it's not going to be the exact counter that you think it's going to be. Here's how it's going to work. We have 26, right, letters in English. Right? So instead of using a hash map, we're going to use a hash map, but we're going to use an array to count how many letters there are. So what that means is, so say we have E, right? E is 1, A is 1, T is 1. We're counting the letters in E. And then everything else, 0, right? Z, 0, Y, 0, etc. Right? The way we can portray this is actually really freaking smart. We're going to use an array of size 26. And it's going to be literally 0 to 26 as the indices, right? And let 0 be A and 26 mean Z. Okay? So we're gonna let A be 0, Z be 26, or I guess 25, right? Because 0 index. Okay? We're gonna use this array, and we're going to iterate through the strings. Hold on one second. Let me just make sure I'm doing everything right. Yes. All right. So we're going to, as we iterate through this through each string, right? Each string is going to have a unique counter. So eat would be A would be 0, B, C, D, E, 0, 0, 0, 1. Then sorry, A would be 0, 1, 1, dot, 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 and then T would be 1, dot, 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 0. Okay? So again, just to talk about what we're doing, we're using a counter. And again, this is a pretty crazy solution. We're going to have an array, and the array is going to be our counter. From 0 to 26, we're going A to Z. Once we hit that number that we prefer, so say A is 0, right? E is 1, 2, 3, E is 4, right? We're going to add 1 to the counter for each time that letter shows up. We're going to use these now as the key, because eat, 8, T, they all have one E, one A, one T, right? One A, one T, one E, T, E, A. So they're all going to have the same array. Does that make sense? Does anyone have any questions about that? They would all have the same number of letters counted. Before I move on, does anyone have any questions about what we're going through? So we're counting each letter, we're using an array to count it, and if they're an anagram, they're going to have the same array. Okay? No questions? So I'm assuming you're all following? Cool. So, we're going to have this count. So for character in, sorry, so for string in strs, so for each string in this strs over here that we have, for each string in this strs, we're going to create an array. Count 0, 0, 0, 0, 0. That's 26 size, the size of 26, okay? And then within this loop, so it's gonna be a nested for loop. But don't worry, because it's technically O of m times n. All right, so we're gonna have a nested for loop. So inside, let me see if I can move this actually. There we go, perfect. So then for each string of strings, we're gonna create an array, and then for each character in the specific string, right? So now we're going go back over here. Let me just copy this example. Oh, I can't do the whole thing. Never mind. Okay, so what we're doing is we're going for each character in string. So for each word in string, we're going here, right? And then we're going to iterate through each character. So here's a different pointer, right? This is what we're doing. We're going through each word in string, and then we're going for each character in each word. So for character in string, we're going to add the count of whatever of letter, right? Letter 0 to 25. Plus equals 1. So for each character, we're adding 1 to that count. Okay? And then we're just the same thing as before. Answer, right? Count, same as before, append S, and then return the values. So this is sort of like the pseudocode of that what we're doing. So we're going for each string, we're creating an array, and we're counting each letter, and we're adding 1 to the count, and then we're just adding that word to whatever it shows up in there. So we would have already created the array. So at this point, we created the array already. So we put it into this over here, right? Which should be the key, and we're adding the string into there. All right. So this is sort of like the overview of what we're doing. Does anyone have any questions about this, or am I gonna just go straight into the code?
Can you explain what the last line does, or ants count dot append?
Okay, so it's the same thing as before. So what we're doing is that we create at this point. Let's go step by step, right? We went through each string. We created an array, and it's empty, right? 0 all the way from 0 to 25. And in this array, we're going to count up each letter. So we talked about before, right? Like A is 0, so we add. So for E it'd be 1. E is 4, so it'd be 1 over here, and then somewhere where T is it'd be 1, and everything else would be 0, 0, 0, 0, 0. So this is a unique array. This is counting 1E, 1A, 1T. This is what this array is saying, right? So once we've counted, so here's the for loop that here's the for loop that we were in. Why am I keep erasing? This is the for loop that we're in, right? In this for loop, we're just counting everything. So we're going in there and saying, okay, there's 1E, 1A, 1T in eat, right? So eat equals S. So for each character in eat, we're adding 1 to that count. And then afterwards, this array has existed now. So we have this array over here. This guy right here, he exists, or she, or they. They exist already. So we're going to put that into this. This is the key, right? The count. So this big array is the count. And we're just adding that word to it. So it's if say like 0, 1, 1, 0 is means 1A, 1B, right? Any word that comes up with this array over here, right, would be added to the list. It's sort of the same idea as before, where we had the sorted thing, where like every word that was AET when it was sorted would be added. So it's the same exact concept. Does that help a little bit?
Yeah, that helps. That helps.
Cool. All right. So now moving on to the code. So hopefully that made a little sense. Again, it's a pretty wild idea. We're using, instead of using like a string or character or anything else as a key in a hash map, we're literally using a whole array as a key. And the value are the words that fit that array of counting of characters. So it's pretty out there and just a really cool way that you can use a hash map to make things way more efficient. So let's go over here. Group Anagrams. So here again, this is the old code. I'm gonna comment and just drink some water. All right. So we're commenting this bad boy out. All right, let's try this again. So before we sorted stuff, so it was O of n times n log n, which is pretty inefficient. Whatever. Let's be smart about this. So we're gonna do the same thing as before. We're gonna create an answers dictionary. And we're gonna use default dictionary, and we're starting it as a list. So empty hash map, right? Default value is a list. List. There we go, list. Oh my god, I can't spell. There we go, list. All right, this time, again, for S in stirs, again, see, it's the same exact idea, but now we're going to create count equals, and here's again Python just being nice. What we're doing is create an array of size 26 with all zeros. That's all we're doing. We're creating an array of size 26 with all zeros. Okay? And now we're nesting a for loop. This is where it becomes n times n. But it's not n squared because the size of stirs is different from the size of each string. So this is not n squared, this would be n times n. So for C in S, what this means is for each character in string S.
You said n times n. Wouldn't it be n times m?
No. Yeah, that's what I said. Sorry, I mispronounced. Okay, so for each character in the string S, we're going to add the count. And now here is where we use Python to, or not Python, it's actually just basic things. So how can we make it so index 0 equals A, 1 is B? How do we figure that out? Does anyone have any idea how we could figure this out?
Let me guess. A hash map.
No, we're already using a hash map.
Oh, never mind.
Think about, this is like CS 111 stuff.
I was
Right?
thinking ASCII
How
table.
else? ASCII table, yes. Who was that? You are a genius. Who said that?
That was
Shmeez?
me.
Okay, who Shmeez? That's a nice name. So Shmeez came up with, yeah, we used the ASCII table. So here's where we can use our big brains that you learned in CS 111. Right? I'll look up ASCII table on my actual thing. ASCII table. Because I don't have this stuff memorized.
I think it was like 60 to 90. That's what I remember, or some shit like that.
Yeah, okay, so
60,
okay, so apparently
65.
A lowercase a is 97. But just for basic stuff, let's just call it 80 because it makes more math, right? So then but we want A to equal 0. And let's say B, let's just pretend, right? This is not right because it'd be 98, but we want B to equals 1. What can we do? Anyone have any ideas? No, you guys all gave up on CS 111? Okay. I'll give you the answer. What if we subtract the ASCII value of current character minus ASCII value of A? So say C, where we are at C, which say is equal to 82, minus 80, which is the value of A. In our theoretical world, it's actually, but again, this is just simplifying because A is 97, means that it would be 2, which makes sense to our array. Does that make sense to everyone? We're using the ASCII value, and we're just subtracting it from the ASCII value of A to create our 0 index count, because ASCII is just weird. So the way we do it in Python is just called ord. Again, just if you don't know it, you could probably just Google it real quick in like a technical interview. I'm sure they'll let you check that out. But all we're doing is we're subtracting the ASCII value of the current character minus the ASCII value of A, lowercase a, right? Plus equals 1. So we're adding 1 to the count. So add 1 to the count of whatever we are. Okay? Like, oh my god. There we go. And then we're just going to append it. So then answer. And again, we have to use tuples because Python is just like that. We can't use arrays or lists because again, they're immutable objects, but just no tuples the same thing. Append s, so now append the string s that has that specific letter count, and then return the values of our hash map. And if we run it, it works. And if we submit it, it works. Again, the runtime, again, the reason why it says beats like almost no one is because people are using some weird, like, crazy solutions that just make no sense, and they're using like all these built-in Python functions that are compiled in C, and they're just kind of cheating to get the best, fastest solution. But in terms of actual big O, which is what you should care about, this is actually the most efficient solution, which would be big O of n times m, with n being the length of stirs and m being the length of each string in stir. Okay, that's the solution. Any questions?
For this one here, for some reason, I did the same approach that we did for the first part. Not for this one, for this first part. My runtime was 5 milliseconds. And I think yours was 108. I don't know why though.
Oh, you were using Java, right?
Yeah, I did it in Java. That's the one I just sent.
Yeah, so again, each language has different runtimes. So, quick aside, the reason why we use Python in technical TPs is because it's a lot easier to come up with these solutions. But something like Java, or especially something like C or C++, they're much closer to the actual assembly language that computers understand. So technically, they will run faster. So the runtime doesn't matter. If you were like doing like a data set that's like a billion different things, maybe you might want to make this in C so it's more efficient and you're running it all the time. But for something like Leetcode, I would just use Python. Don't worry about the runtime. Java will always be faster than Python, and C and C++ will be way faster than Java every single time. And that's just the way of the languages, but they all have their pros and cons. You don't have hash maps in C, so you'd have to make your own. So, you win some, you lose some. For this, you're just trying to solve the problem, so your runtime will be slower than Java, but your big O, which is n times m, is the one that the people care about in technical interviews. They don't care if your runtime is 5 milliseconds because it's Java. Does that make sense?
Yeah.
Yeah. And I think some people have solutions and like these things where it's like best solution and it's like beats 99%. Sometimes it's like some weird Python thing that just makes no sense, but using some magic they make it faster. So don't worry about those. This is the efficient solution in terms of big O. All right, any other questions for the last question for Leetcode Friday? If not, then I'm just going to quickly summarize. In essence, when you're doing Leetcodes, always think, can I use a hash map? Because you can use a hash map in almost every single Leetcode problem these days. Lots of them use hash maps. They're great for counting stuff. They're great for just searching for stuff. You can use a hash map for almost every single question if you really think hard enough. They're really efficient for searching, which is why we like to use them. In the end, Python is really easy for that because you can use default dict and counter to save you a lot of work. Any questions at all before we end the session today?
That's kind of like where that joke comes from, where a lot of software engineers they say like, if you don't understand a problem, just throw a hash map at it. and a lot of the times you'll be able to solve it with a hash map. So, in your Leetcode journey, try to master hash maps because they're very useful.
Yep, exactly. If you don't know what to do, just think, can I use a hash map? Like whenever you're going on a LeetCode problem, literally just stop, think, does a hash map fit in this problem? Chances are like maybe like a third of or half the time you might end up being able to use a hash map to solve the problem. So it's really cool to learn to practice these. And again, LeetCode is awesome. They have a roadmap over here, right? Where you can go through different problems. Arrays and hashing is one of them. These are where you literally just use hash maps. So again, we use duplicate valid anagram, two sum, group anagrams, which is the one we did just now. These are all hash maps. He has practice. You can go and Leetcode all. If you want 60 different hash map problems from easy to medium to hard, well, here you have 60 hash map problems. And you are going to use hash map in stacks and binary search. Use hash map. Like min stack, I think I use the hash map. Or I didn't use the hash map here, but yeah, I think parentheses, which is a stack question, I used the hash map. So yeah, that's pretty much it. Hash maps are life. Learn Python. Do Harvard CS50 if you don't know Python. You can do the CS50 Python class itself, which is a full course. If you want to start from the beginning and you're like in 111 and you just want to learn Python for real, it has everything you need to know. Or else you can just do CS50 regular, which is the original Harvard Intro to Computer Science. Week 6 has a crash course on Python, which is like only 2 hours, and it has literally everything you need to know. Literally everything. So, yeah. Alright guys, that's about it. I hope you have a wonderful LeetCode Friday. I'll see you all next Friday. We're going to be going over binary search. So practice your binary search, because we're going to do lots of those binary search problems next week. Alright guys, that is it from me.
Enjoy.
Thank you.
Welcome. Have a great day, guys. Have a good night.
All right. You too,
All right,
George.
man.
Later.